All right, example 2 shows us the average viewership for the Super Bowl in numbers of households. And they want us to generate an exponential function model for the Super Bowl viewership. So we want an exponential function. How many households do your model predict will watch the Super Bowl in 2018? So first thing with exponential, just like anything else, check the x's. Plus 1, plus 1, plus 1, plus, good, they're all plus 1. And so we'll start checking the ratios. 27,670 divided by 2301, 27.670 divided by 23,050, we get 0.0012. Okay, I wrote it wrong. 23,050 divided by 27,670. There we go, 0.833. So it's time 0.833. 29,440, 29,440 divided by 27,670. We get 1.06. So 1.064 times 1.064. And we can round that third digit in a little while. Keep on going. 35,090 divided by 29,440, 29,440. You get 1.192 times 1.192, and then last but not least 40,020 divided by 35090. You get times 1.140. All right, so I know this one may feel a little low compared to the rest of them. I get that. It might be a little bit of an outlier. But they still said generate an exponential function. So even though it's not perfect, we're going to still generate it because that's the instructions. So to do it, remember, add them all up. We're going to add all 4 of those up, and we're going to divide it by how many there are. Well, there are 4 of them, so add them all up and divide by 4. Real fast. Let me pause it. I'll do it. All right, and the average is, so the average change is 1.0697. So I'm going to do 1.070, and I just won't draw the 0. So 1.07. That'll be my average. Okay? And they give us the starting point. So your y equals, so this was y equals your starting point, 23,050, 23,050 times 1.07 to the x. That's our equation. Yay! That's the first part of what we need to do. Then it says predict how many will watch the Super Bowl in 2018. Well, 2018, we need to find the x value for that. So if you notice here, we're going up by 3s. So 2018. So 2018 minus 1982. That's 36 years. So we got to add 36 years plus 36 years. But we're going up by 3s. So we need to add 12 to that to get to the x value. All right, because remember this one is going 3, for every one of those steps, it's going 3 of those steps. So 12 plus 4 is 16. So here we go. Y equals 23,050 times 1.07 to the, what did we say, 16th. And that will be your answer. So y equals 23,050 times 1.07 to the 16th. And we get 68047. We say 0.3, but we're estimating people, so we're going to leave it at that. That is our estimation, 68,047. Right? Which, that doesn't seem like very many, but it is what it is. Go ahead and try. You try me number 2. All right, you try number 2. It says a biologist places a single paramecium in a petri dish and observes the population. And then you scroll on down, it says generate an exponential model for the paramecium population. How many do you predict will be in the petri dish on the 10th day of the experiment? Okay, so first things first, we got to get our ratios. So, it helps if I get a pencil. 2 divided by 1 is 0.5, so that's times 0.5. 5 divided by 2 is No, 2 divided by 1 is 2. What am I thinking? 5 divided by 2 is 2.5. 10 divided by 5 is 2. 22 divided by 10 is what, 2.2? 22 divided by 10, yep, 2.2. 44 divided by 22, well, that's also 2. 87 divided by 44, I don't know what that one is, divided by 44. 1.977, so we'll do times 1.98. We'll give it 2 decimal points. All right, so those are all really close. So to generate the exponential function, add them all up and divide by, so we'll add up all of those and divide by 1, 2, 3, 4, 5, 6. Divide by 6. Give me just a second. And we get 2.11. That is our average ratio. So your equation, we'll go here to the left. Your equation is y equals your starting point, that's a, so we started with 1, which we don't have to write times 1, times your ratio to the x. Well, my ratio is 2.11 to the x. And then they say, how many paramecium does your model predict will be in the Petri dish on the 10th day of the experiment? Well, you'll notice the days are 1 more than the x value. So the 5th interval is x is 5 when the day is 6, x is 6 when the day is 7. So when the day is 10, x is going to be 9. All right? So we need y equals 2.11 to the 9th. So 2.11 to the 9th is 828.9. So I'm going to round that to 829. So that's our prediction, and that's our model.